antiderivatives, we can talk about something called differential equations. So you guys have heard probably that after Cal 3 or with Cal 3, there's something called DiffEq or differential equation. The whole entire course, we are only solving the most basic differential equation in this class. So here it is. Differential equation. Finding an antiderivative for a function, little f, is the same problem as finding a function of y that satisfies this equation. This is called a differential equation because it's an equation involving a derivative. So dy dx is why we call it a differential equation. So to solve a differential equation, your goal is to solve for y. What function y, when you take the derivative, equals the little f? To solve it, we need to find, I just said that. So this function y is found by taking the antiderivative of the f on the right-hand side. So you notice here, they've given us dy dx, and they want us to find y. Well, for our purposes, this is not crazy talk. This is just saying, here's the derivative, find the antiderivative. So y is going to be the antiderivative of this derivative. All we're asking you to do. Giving you the derivative, 10 minus x, and saying, now undo it. To undo a derivative, you integrate. Alright, so what's the antiderivative of 10? 10 is a constant. What would I have to have so that when I take the derivative, I get a constant? Well, if I had 10x and I took the derivative, I would get 10. There you go. The x here has a power of 1. Let's try to power roll backwards on that one. So we would take power of x, we would add 1 to the power. So that would be x to the 2. And then we would divide by the new power. Or 1 over the new power. There you go. You take the derivative of that, you get negative x. So it worked. Don't forget your plus c. Alright. We also are given this initial value. This is actually initial value because the x value is 0. So your x is in the parentheses and your y is the answer. We can use that to solve for c. So we know that y equals 10x minus 1/2 x squared plus c. If they're telling us to plug in 0 for all of our x's, and they're saying that this has to equal negative 1. Well, with that information, we can find c. Because 10 times 0 is 0, and 1/2 times 0 is 0. So c must equal negative 1. With that, we can rewrite y as a particular solution to this differential equation. There you go. Alright, before we continue, let's try and write down some rules for us. Integration rules. Alright, if you integrate 1 dx. Technically, you don't have to write the 1. If you just see integral of dx, that means integrate 1. The answer here is x. If it had been the integral of any constant c, you would just leave the constant there. So, for example, if I had the integral of 5 dx, you would just leave the 5, which is a constant multiple, and you would integrate dx and just end up with x. Don't forget the plus c's. Plus c. Alright, what if we integrate x to the n dx? That's the power rule backwards. You add 1 to the power, and then you divide by the new power. The integral of 1 over x. Remember, this is if n is not equal to negative 1. And it's equal to negative 1 here in the next case. That one is going to be ln of, oh, I forgot the absolute value when we did that problem. Remember, ln, you can only plug in negative numbers. So if we integrate, we actually have to put the absolute value. Right down. There it is. So in this problem back here, we actually needed absolute values on this x. I just completely forgot. Alright. We also talked about the integral of a to the x dx, which is a to the x divided by ln of a. The integral of e to the x dx is e to the x worrying behind functions in the power right now. I'm just doing the basics. True. The integral of sine of x is negative cosine of x. Why? Let's go back. Take the derivative of cosine, you get a negative. By having another negative there, you end up with positive sine of x. The antiderivative of cosine of x is positive sine of x. Because the derivative of sine, I go from the right hand, the derivative to get back to the left hand side. The derivative of sine is cosine. The integral of secant squared of x dx is tangent of x. Because the derivative of tangent is secant squared. And the antiderivative of secant of x, tangent of x dx. Remember, secant, tangent, the order you write them in doesn't matter. If they're multiplying, then the antiderivative is secant of x. That's everything. Double check real quick. Power rule, cosine, v, exponential, tangent, ln. Yeah, that's all of them. Wow, that's a lot of rules. But remember, these are all the same rules you already know. You just know them in the other direction. Alright, so we have one word problem here. This is the last part of this section. So a hot air balloon ascending at the rate of 12 feet per second is at a height of 80 feet above the ground. Alright, so we actually have a picture here of the balloon. So they're letting. Alright, hold on. When a package is dropped, how long does it take the package to reach the ground? So we're looking at the package. The package is being dropped. So the package is going to have a velocity, an acceleration, it's going to take some time. Alright, let's see. If the hot air balloon is ascending at a rate of 12 feet per second, and the package is in the hot air balloon, so think of it as the hot air is going, the balloon is going up, they're holding the package. So initially, that package is traveling with a positive velocity going up in the hot air balloon. So the initial velocity of that package is actually 12 feet per second. Initial velocity. Sorry, dv dt is not initial velocity. V at 0. Okay. Sorry. Yeah. I don't need to write dv dt. That'd be acceleration. Alright, so the initial velocity is 12 feet per second. That's for the package. Yes, that's what the balloon is doing, but the package is in the balloon. So then they drop it. The time at which they drop it has a height of 80 feet above the ground. So that's our initial position. That's s at time 0. 80 feet above the ground. And the package is dropped. How long does it take the package to reach the ground? Package to reach the ground, what does that mean? We don't know anything about the velocity, because we're going to have a velocity at impact. We don't know what that is. What we do know is the position at that time is going to be what? Well, we measure position from the ground, so at the ground level, the position is 0. Okay. So if we know, alright, so back up. What do we know? So this is a package that is in free fall. We've talked about free falls before. When you have a free fall, what we do know about this package is that the acceleration, assuming all is simplified, the basic acceleration is simply the gravity. So the basic acceleration anytime throughout this object falling is going to be negative because it's gravity. Gravity is pulling it down to Earth. And in feet, this would be 32 feet per second squared. So this is at any time t. Which means this is a function of t. Now, what we need to do is get back to s. Why do we need to get back to s? Because that's the problem we're trying to solve. We're trying to find t that makes s equal 0. So to do that, we're going to start at a, which is a function of t. doesn't involve a t because at every step of the way it's negative 32. But we can use it to find the other functions. V of t is the antiderivative of acceleration. We're doing position, velocity, acceleration, but we're doing them backwards. We're starting with A, and we're working our way back. So write this out real quick. So remember, we had S of t before. So we talked about him. He's a position. Then we talked about how V of t is the derivative of S of t. And we've talked about how A of t, the acceleration, is the derivative of velocity, or the second derivative of position. Well, now we're going to go backwards. We have A. To get back to velocity, we take the antiderivative. So if I work my way back, the velocity is the antiderivative of acceleration. I'm going to put dt here because it's our variable t, not x. To get back to position, we have to go backwards. So we take the antiderivative of the velocity with respect to t. We're not going to talk about double integrations. We do double derivatives. We're not going to talk about double integrations until you'll get to PAL 3. So have fun there. Do one at a time for our class. Alright, so to find the velocity, we have to integrate A of t. We need the antiderivative of negative 32. I just reminded you, we have a number, the number just chills out. Negative 32 chills out. We're integrating dt. Remember, when we integrate just dx, we end up with x. Integrate just dt, you end up with t. Plus your constant. Don't forget that constant. That constant, though, can be found by using our initial condition. So if we know that v of t is negative 32t plus c, we can use our initial condition that v of 0, plug in 0 for t, is equal to 12. 32 times 0 is gone, it's 0, so c equals 12. Now, our velocity equation, we can fill in our c. 32t plus 12 for our c. That is not the answer to the question. To get the answer to the question, we got to make it all the way back to x. So how do we get to x? We take the antiderivative of the v. So we need the antiderivative of negative 32t plus 12. Well, this one here involves t to a power. So let's use the power rule backwards. 32 is just going to chill out while we take the antiderivative. So negative 32. T, we add 1 to the power, and then we divide by our new power. Plus 12. Well, it's a constant. We have a constant, just like we did a minute ago. You just put the variable next to it. That's the antiderivative. Plus our c. So if that's our s of t, we can use our initial condition way up here. Initial position of our box, s of 0, plug in 0 everywhere. If you plug in 0 everywhere, all of this is going to go away. You're just going to end up with c. S of c is 0, and we know that s of 0 is 8. So with that information, s of t is what we found. So negative 32 over 2, that's negative 16 t squared, plus 12t, plus our c, which we discovered was 8. To solve the problem, we want to know when this equals 0, when the object hits the ground. That's the equation that we have to solve. How do we do that? First of all, I see something that can be factored out. So we can actually pull out a 4 or a negative 4. So 4t squared minus 3t minus 20. Nothing else can be pulled out. Alright. Let's do quadratic. Why? Because I don't think that can be factored. Could be wrong. Let's do quadratic, we'll find out. So x is what you usually write, but in this case t. So negative b plus or minus the square root of b squared minus 4ac, all of it over 2x. So here's your a, your b, your c. Just the numbers, not the letters. So negative our b, so that'd be positive 3, plus or minus the square root of b squared is 9, minus 4 times our a times our c. working it out. Let's see what we get. So inside the square root, we get 9, and then those three numbers become positive. 4 times 4 is 16. 16 times 20 is 320. All over 8. 3 plus or minus the square root of 329 all over 8. And we grab our calculator because 329 I don't know the square root of, or it has a square root. 329 is the square root. That does not have a square root. So this is 3 plus or minus 18.14 if I round, all divided by 8. Remember, the plus or minus means you technically have two answers here. You have 3 plus 18.14 over 8, and you have 3 minus 18.14 all over 8. So 3 plus 18.14 divided by 8, 2.64. Remember, this is time. Time is in seconds in this problem. The other one, 3 minus 18.14 divided by 8 is negative 1.893. Alright. Now, is it possible for the object to hit the ground 2 different times? Well, no. Well, it might bounce up and hit, but we're not considering that possibility. The object falls and it hits the ground. What's wrong with this? Why do we have two answers? We cannot work with negative times. We cannot go back in time, so we cannot work with negative times. So this would be the answer to the question. Alright. Have fun. Try them out. Work on it. If you cannot figure it out, if you have a particular question on homework, email it to me. Press the Ask My Instructor button. Great. But email it to me. If there's a particular thing that you want me to make a video on, please let me know. But remember, we're going to do more of these as we go through derivatives. So if you want to start the next video and see if that helps clarify, great. But you do need to be able to do basic antiderivatives. Don't go too far into the videos without figuring out what the heck is going on here, because it just builds from here on out. Alright, that's it. That's all for 4.8. Email me if you have questions.